Means a lot when a lot of people take your time outside of your work hours. You want to learn something, you want to contribute to something. Whatever the idea is, that's good that you're taking your time out, and I really appreciate you for that. Thank you very much. So quickly, let's start with the first line. Of course, I have a little small change in the title. I call it as Pentest 101. But at the bottom, I do have a tagline which says software testing for security testing. Before I jump ahead, before I actually, give a little bummer talk about who I am, quick question. So, how many developers are here today? That's good. We have two of us. Okay. How many software testers are here? Okay, that's a good audience. I'm raising my hand again. Anyone from security background? I have to raise my hand again, unfortunately. That's okay, but the idea is simple. I want to give you guys some ideas, tips and tricks on how you can think of it as borrowed knowledge or intuition that you could use during your software development or as part of your software testing in general. Simple ideas that could pretty much change how you test software today, how you look at a web application or any application in general. I'm not here to brainwash you, rather just to tell you that you can look at apps a bit differently than how you look at it today. So about me, I've moved to Australia a year back. Previously I was living in the States, had my education there. Have a master's degree in information warfare, cyber and information warfare. The title sounds a little scary, but it's not really. It's fun because all you learn is about how to break things, what's going wrong, how do you fix it, how do you strike the balance. One of my favorite topics would be software assurance. I'm a hobby software developer, which means I write code just for fun. Sometimes I contribute to random open source projects. I'm a contributor with SPDX, which is a Linux Foundation work group. Anyone familiar with Linux Foundation work group? That's okay, you can look it up. It's a cool governance platform kind of thing for all open source in general. But ask you to look out and see what Linux Foundation does. It will be really interesting stuff. Right now at Melbourne, what I do is I'm a security designer at UniSuper, which is 2 blocks away from here. Walking distance, basically 10 minutes away from here. Day in, day out, I look at applications that are being developed. How can something be fixed? What is going wrong? Whether it's being deployed on on-premises, data centers, cloud, doesn't matter, but something that is an application or something that requires security as part of application features, that's where I bump in. And the agenda is simple. We go through some small basic things, what pen testing is in general, and where it comes in software development life cycle, and why it's an interesting or important topic when it comes to software testing, software assurance in general. And that's pretty much the majority of the audience today as well. And yeah, I think I failed to finish my sentence there, but the idea is to get out of the tips there. So, quick 3 things. So, anyone familiar with the term pen test? What pen test might mean? Have you heard of the phrase pen test? All right, don't be shy, guys. No one's gonna give you money or take away your money for this. Feel free to participate. So pen test, we will go into the definition a bit later, but just to exercise that this is actually what it means. Software security. Please shoot out if you have any definitions of what you think is software security, and same with information security. What do you think, what these terms mean to you? Oh, come on, there must be some answer.
So information security, so making sure that we understand the tier of information, whether it's a secret, or whether it's confidential or not, and how we store it and so on.
Part of it.
Yeah.
Information security, basically considering layers of security in the overall information landscape, and also including the data and everything.
Yeah.
And software security is securing the software itself.
Any other?
Information security is about ensuring the integrity of
information in general.
Whatever, no matter how you do it.
Yeah.
And security, I think, authorization and authentication. That's the most.
Yeah, the problem with information security in general is the definition is very vague when it comes out to wider audience. When you say the word cybersecurity or information security, it is so open for interpretation. But the real meaning behind cybersecurity, information security, is actually very simple. Let's say you have a business, say ANZ for example. Hopefully no one from ANZ here, to throw tomatoes or eggs on me, but ANZ has to operate on a daily basis as a bank. ANZ has customers, so to continue operating as is, or to have their business as usual, they need to do certain activities, which is basically balancing between business requirements or how their business is operating versus trying to deal with legal definitions on how they're supposed to operate or try to prevent threats from basically compromising three important things: confidentiality, integrity, and availability. Availability means business is available. It's a public holiday, but you still have your bank app available for you, right? Imagine a day where bank says, hey, it's a holiday, Sunday, I'm not going to open up. That's weird, right? So you want your app to be highly available at all times. That's one big ideal for information security. Integrity means, hey, I have made a transaction, which means it's a fingerprinted way or a forensic proof way of saying that you have actually made your transaction. Imagine you have sent someone $100, but it went from your friend's account. That's no more integrity there. Confidentiality could be, hey, this is the X dollar figure in my savings account, but you're the only one privy to look at your information. Or the flip side of it is you can say it's privacy or need to know basis. But these three are the governing principles that basically define information security to just make the business work as usual. You want to operate your business on these three principles, that's pretty much it. When it comes to software security or software assurance, it's about giving a confidence, statistically speaking, saying that, hey, we have a 95% chance to block something like cross-site scripting or SQL injection. That's a confidence vector telling the business that, hey, in a given threat landscape, if there is malware, we will stop it. If there is a kid sitting in a basement somewhere in Canada or France, we'll be able to stop that. In case there is a dedicated hacking group or advanced persistent threat, we might be able to detect and stop or minimize the extent of breach. But if it is a nation state actors, say China, Chinese government or Russian government, or maybe Uncle Sam wants to get into your business, we can't stop. So that's the confidence interval that you try to achieve, saying, my business will operate as usual, but here is the landscape that I can stop threats against. So there are of course many more interpretations that we can come up, but what gets construed is people being stuck with the idea that software security or security is generally about firewalls, antivirus, network switches, routers, funny dashboards. So that's all the technology part of it. The actual things that make these things run is process and people. You can always get tools, technology, but process and people is how you get things done. Now, speaking of process, before we look at all the boring stuff, there is one more boring stuff that I'll leave it to you guys to explore later. It's called CWE, Commons Weakness Enumeration. So, quick question. So, when say you're writing a piece of code, or when you're testing a piece of software service, general software testing, you write unit test cases, or you have general regression tests and test cases, smoke testing, so on and so forth. Is there a reason why we do that?
Find a bug.
Find a bug. But once you find a bug, it's usually advertised back to the developer saying, hey, there's a bug, you need to fix it. But day in, day out, you keep seeing these bugs. Imagine there was a pattern for these bugs to tell a developer or to actually share it with a wider group, wider audience, even outside your organization, saying, hey, these things are following these patterns, you have violated a specific pattern. Wouldn't that be great? It's easy to share information across, not just your organization, but outside your organization as well. Now, out of this software, let us at the moment assume that all software bugs have these patterns, but of which there is a tiny subset which are security bugs. Now, how many have read news in the recent past few weeks or months that some random organization got hacked? Any new in the recent? And we have had tons more just in Australia, and the statistic by the Australian government is 1 in 4 are already victims. I don't know, you have to just check your accounts, just play safe though. But setting the scary part aside, it is actually a real thing that is happening. Because if the government is giving the statistics, I do believe that the government is giving the right information. But yes, there is proof to believe that it is actually much more serious problem. So these patterns for software security or security bugs in general became more organized, more thorough. But there's still a small subset inside software testing lifecycle in general. So go ahead, read the specs. This is how it's going to look like in a development view. It's going to talk about some behavior problems, handlers, errors, and etc. But actually, when you start looking at it more closely, it's more properly organized. There's a proper tree structure. But just to remember that this subset, which is about security bugs, is a small subset of software testing in general, or it should be the way of saying it. But again, before we start, quick question. Is anything wrong here in this picture? Yeah. Or what is good in this picture, should I say? I have the picture a bit overlapping. So what's good in this picture? The sheet, yes, that's good. That's a good observation. So otherwise it all looks good. It's probably Chrome 75, whatever version it is, dark mode, whatever, all that stuff. But the connection is secure, right? Looks good. Let's have a look at this one. This looks a bit better because from the previous, there is no green lock, and this one I have a green lock, right? Well, imagine you go to your bank website and you see this green lock. You immediately have this confidence saying, hey, I'm going to the right place, or this is a secure site, right? How many of us get that feeling all the time? Or at least most of the time. Let's not be shy. Green lock means good, right? Means go ahead, you're doing the right stuff. But let's look at the next picture. So I've typed in the word secret. You can replace that word with whatever you do in your private life. Or if you're searching for something, and if it is going via the browser URL, what we call as URL, it means someone has the ability to look at what you're sending. In this case, maybe my ISP can look at it, or maybe someone's sharing the same Wi-Fi can also look at this information that I'm searching for something. Or if you're sitting inside an organization which has web proxy or something of that sort, some filtering program, everyone who accesses filtering program pretty much knows what you're searching on Google for. So, well, it is green, it's all good, using I have all the valid symbols saying that it's private, but hey, it's not really private. So the conclusion is simple. Sometimes there are cues in our life that we just assume that it's going right, but it's probably not. So now there has always been a wider discussion about sure.
What if an incognito version of
it doesn't matter. It doesn't matter because the word secret, which is searched on here, is actually going via the URL. So regardless of in private, what in private actually does is that session alone, your browser session alone, is run separately, and once you close it, it's gone. But what you have searched on the internet is not actually. It's actually flowing on the network. So imagine a boundary, okay? Let's take house for an example. Your physical boundary, your control for your boundary is as much your house can extend. The moment something happens just beyond your boundary, you have no control. Now let's invert that back to something that we can visualize. Say you have a laptop, something leaves your laptop, you don't actually have control over it. The moment it leaves your laptop, it's not yours, it's someone else's property. And that's exactly how the internet works. No one controls it. People or governments almost try to assume control. But hey, we have pirated stuff that is available all the time, right? We see pirated movies, maybe, I assume. Not we, I should say, not me. Well, not exactly me. But things that we do in our laptop, we assume that it is something that belongs to me. It's confidential for me, but that boundary is pretty much broken. So imagine if this was a banking application or a financial application or something. Someone is searching for some content, and that sensitive content is available in the URL. It means everyone in that person's network pretty much knows what this is. So confidentiality can be lost, and this is one example. Or the other way to say it is security and privacy go hand in hand. Confidentiality and privacy pretty much come into the picture at that point. The goal is just to tell you this fact, and that is the instance, that is the reason why I put Google. I wanted to pretty much use a random web application where, this is a simpler example, that's all. So now coming back to the definition of a pen test, or penetration test, how it's called, is basically a validation saying, hey, here is a piece of software, or here is my organization, how it works and operates. I want a third party, or I want someone to validate that my design is valid, or it is exactly how I intended it to be. Like say for instance, I'll go back to ANZ here. ANZ says to log in or to use the mobile applications, someone has to enter their CRN, a password, and then go through certain other authentication mechanisms saying, hey, here's a code that we've sent over SMS, or here's a two-factor code, or maybe just use a fingerprint, will allow you to log in. So that's a valid design, but what if there was a different way to log in? And the intent is to see if the design can be broken, but only if the party is allowing it to. So if I'm ANZ, and if I say, hey, Raj, can you break my application, and write it on a note saying, hey, this is the legal binding between us, it's a penetration test. So the only difference between a hacking attempt and pen test is the legal binding. Now, in a typical everyday organization, what we see or how people visualize security to be is almost like this. We have network routers, firewalls, antivirus, and content filtering programs, and you have VPNs to come in from outside world to connect back into your office network, so on and so forth. You have passwords flying here and there inside the network, as well as other security tools like intrusion detection and prevention programs. This is the typical view that as much as a software developer or software tester, software assurance tester, the right term for it. This is the extent that generally people visualize, but things actually go much beyond. If you look at the confidentiality, integrity, and availability that you're generally concerned about. But however, pen testing is simple. You have four different phases or 5 different phases. So if you once have the legal agreement, then you have a stage which is reconnaissance. We'll be looking at reconnaissance today. And this reconnaissance is something that is going to help you how you start writing a few of your test cases. So once someone does recon, it's pretty much the same word that you hear about in movies. A UAV looking at something down from 10,000 miles and saying, hey, here's a moving vehicle, here's a target for you. Similarly, reconnaissance is about finding your targets. So going back a step towards software testing is your targets are usually a piece of software service, something that you're about to test. By recon, it means that you're trying to grab some information ahead of time, saying how does it work, what makes this particular piece of software work and run, and how do I test it, basically. Now once you have your recon done, the next stage is scanning, or in software testing world, the stage would be basically writing your test cases to basically invalidate a piece of software or software service. And of course, in pen testing, the whole idea is to basically gain access, become administrator, extract or infiltrate or exfiltrate information based on what is to be tested. And then of course, maintain access means to say that you have permanent access onto a server, or basically it's my bot or something of that sort. So these stages, on the flip side, they're very construed because it's all about security, but on an abstract view, this is exactly how software testing works. You try to find a bug, you try to see that a piece of software is going to fail, or your test cases are almost around to see that something fails or passes. Pretty much the same process, but in a little different. Sorry about my screen lockouts. Now I'll leave this slide out. It's just an explanation saying stage 1 to end, how penetration testing is done. You start with a legal agreement and you end with document or a report, but of course you do a retesting. It's the same thing that you do even with software testing in general. You have some, say, Jira ticket, replacing the pre-engagement, the Jira ticket saying, hey, here is a task for you, it has been assigned to you, go ahead, do this. But then you do your reconnaissance, which is about understanding the piece of software that you want to test. Then you do all your stuff, have a report, then you retest saying that, hey, someone has fixed the code, so it's all good for retesting. Previous condition, let me go ahead and check for them. What the real important stuff for us is this one, SDLC. So is it fair to assume that all here follows some sort of SDLC? It's a no-brainer, right? Just add the word secure to it and it becomes secure SDLC. Just saying that, I'm just making that up. But software SDLC, whichever you pick, has a design phase, right? There are a bunch of people, trying to make big decisions, saying here is exactly how it should work like, these are the features, and etc. As part of that phase, in security, what you introduce is, as part of that SDLC stage, you introduce what is called as threat modeling. So our anti-patterns, so we were looking at CW's, the big list earlier. Basically, I'll construct a picture, going a bit ahead here, which looks like this, saying, hey, here is the workflow for an application. I want to see what would potentially break it, but on a theoretical level. Right? We'll get into threat modeling a bit. So the second stage is all about construction or writing code. This is where developers, they become code monkeys suddenly and start writing a lot of code, downloading all those annoying 10,000, 70,000 dependencies for Angular projects or React.js, all the wonderful glory stuff. Then you have a piece of product that is out for consumption. That's where, before it goes to consumption, testing process kicks in. So testing phases, based on the organization, people have different ways of doing it. We have different goals to achieve it. But regardless, there is a testing process. There is an acceptance criteria that testers set saying, this is my criteria to say that I'm signing off on this application. Part of that is security testing, and that's exactly where you guys can leverage patterns, saying, hey, these are anti-patterns in security, I want the developer to fix it. So when we get into the demo, I'll explain a little more of that. But we're not diving deep into vulnerability response. Basically, that's where an application is deployed and security kicks in and says, hey, we're going to monitor this application from now on. It's handed over to us. We are the ones responsible for making sure malicious actors don't break into it. So let's briefly talk about engagement. If ever you were to change your role and become a pen tester or get into security and you're supposed to do security testing, make sure you have some sort of a written approval. Otherwise, do not do it because someone might claim, hey, you're trying to hack. Play safe, or to just cover your ass, basically. Just make sure there is a legal binding or some sort of a written agreement between people and you saying, okay, you're authorized to do this. Go ahead, do the security testing as part of it. So, quick statement, just a quick disclaimer, that's all. Now here's a quick question from this picture. Google.com, we visit it almost on a hourly basis maybe? Or pretty often, right? Use Google.com. But how many here have wondered how Google actually operates, what's behind their servers? What do they do to produce this service pack? In this screenshot, what I'm saying is that, yes, my browser is a bit modern, or latest possible, so supports what is called as HTTP2, right? But Google is operating on something called as, Google Web Server. What is it? So it's a curiosity that made me look at what is really Google doing. Because if you are a consumer on Google Cloud and you deploy web service, you get an Nginx web server. Why are they not using Nginx? What is their stack? What does it look like? So it's just a curiosity question from me there. But this is my reconnaissance saying, hey, this is how Google.com is operating. Now, what we'll do quickly is, does anyone want to pick a random website? We'll just do a quick reconnaissance and then move away.
You like ANZ Bank, yeah?
Sure.
Unisuper.com.
Oh yeah, sure. Not Unisuper today. But hey, as soon as I visit, momentarily I did see a Red Hat logo. And yes, the operating system is Red Hat. Oh, this is juicy information for me, right? But imagine you are a software tester, and you know that this is actually what is happening. This is more than brilliant information, right? So this is reconnaissance in terms of security, but when you flip the button for you in software testing in general, you want to gather some information saying this is exactly what they're operating on. Now let's keep this one private. I don't know what ANC is operating on. So does anyone want a different target or? MME? NAB. Is it nab.com.au? Yeah, I think they're running on one of those front-end, limited information. I see that they're using a CDN, Akamai. That's for content delivery. Believe maybe they're using Akamai for web app firewall as well. Looks very clean, right? But compared to the previous one, this is a lot less information, which means it's a lot less information for someone to attack. But imagine you're writing your test cases for your web application that would actually, be used by your consumers, customers, members, however you want to use the word. You want to make sure that this information is minimized, right? When someone has lesser targets to look at, it's better information for you, or basically, it's a better outcome for your organization in general. So, things that you can test with just a browser plugin. In this case, I'm using a plugin called Backlizer. It's all free, right? Free information, but to your advantage. Now, speaking of threat modeling, it's an activity that is done during the design phase. It's imagine you have a person who is theoretically trying to design, saying this is the potential scenarios where the application could be hacked or the entire environment could be breached. That's pretty much the short way of saying what threat modeling is. But it's a theoretical way of finding out vulnerabilities before using any tool set or anything. It's all about the mindset, but it's all coming back or all driven by the weakness enumeration, the first spec that I did not deep dive into. So that's the reason I'm encouraging you to go ahead and look at that anti-patterns list, because threat modeling or your software design in general is built on top of anti-patterns, saying that if I do this, the application would break. If I don't do this, the application would break. So these are kind of anti-patterns or abuse patterns that we build our applications on top of. So yeah, so threat modeling in the future definitely helpful. But in this case, what is happening is I'm trying to measure how a successful attack would look like if the target is to be a particular web application or a particular business service that is available. So it's all based on theory saying that, okay, I'm trying to target this software vector or software weakness category. So simple to look at, but when you start actually doing this as a practice and include it as an artifact as part of your software testing, it gives you more structured information on how your software tests can help accommodate or help invalidate certain security vulnerabilities to realization. Now let's, a lot of stuff on top. We'll quickly look at the demo. So how many here have ever attempted to hack or break something? Well, software testers, so you have attempted to break a lot of stuff, yeah. So go to this website if you want to, just go to the demo section. We'll be looking at a very quick one. How many here have heard about a term called cross-site scripting? Few hands, that's positive, very positive. But security comes and says, hey, there is cross-site scripting, fix it. And developer goes ahead, reads about it or already knows about it. They start writing code to fix that vulnerability. How does software testing go along with that? How do you validate or invalidate?
So for cross-site scripting, you can maybe it's a web app and it's a field. You can quickly inject a script tag and maybe just put an alert. But if it pops an alert, then you know that it is interpreting it as JS, not as text.
Right.
So in this case, the developer has to encode the input.
Makes sense. That's perfect. That's a very typical, very basic example.
Yeah.
There are tons of ways to bypass that. But here is a quick way that you can test. Okay. In this case, it's not a field, it's a file upload. Right. So file upload and cross-site scripting, you might be wondering, hey, what's going on here? Let's quickly do this. I have a test file. I'll show you the test file, what it contains. Hit the upload button. I have a file uploaded. Okay. the intent of this program is to actually upload an image, but somehow I was able to get HTML file online. Good. But you see, I have JavaScript inside the file, right? Because the file is being executed at this point. Imagine your web application is supposed to just display an image, but suddenly starts displaying not just an image, but something beyond that. Now, the second piece of it, if I go to the second file here, so what I'm trying to do here is, it's pretty much the same demo. The only difference is in this file, I have a piece of code that is doing much more than just cross-site scripting. One, I've already bypassed the control of file upload. I'm able to upload something that is not intended. So basically, I'm masquerading something as image, but it's not really an image. It's a fake signature, but it's just executing code. So imagine if someone were to upload something more bad, like backdoor, Trojan, something of that sort, and if that gets through, well, the company is either in trouble, they're in the news. That's the reason why we read the news that someone got hacked recently, because someone just left off something untested. I'm not saying testers have to take blame, don't read me wrong there, but security gets the first blame because it's not picked up. But hey, how about we change the game and call it as shared responsibility? Security is doing their side of the stuff, but as part of software testing, what if you were to look at this application a bit differently? So when you see, typically when you see an upload, try to see if you can do something more than just what is actually asked for. Like someone says, hey, here is a field for uploading a PDF file. Well, take a PDF file, but